The concept of circular economy has been widely discussed in the GCC and MENA regions, but often without thorough analysis of its theory or its scientific basis. Circular economy is actually a powerful strategy with exceptional tools that can provoke radical changes in the industrial evolution. But in order to fully harness its potential, it is crucial to delve into its roots, theory, and practices, and apply its powerful tools to address critical issues such as resources preservation and waste reduction without compromising economic growth or consumption rates. I may surprise many of you, but the truth is that circular economy is not only about the environment, as some emotional speakers may try to convince us, or just about waste and recycling, as some equipment manufacturers and business owners may lobby for. It encompasses policies, economics, finance, alongside the environment, and ultimately is a way of life. Therefore, let us explore this concept further. To begin with, it would be helpful to summarize our journey in exploring waste management, organization, and economics in order to refresh our minds. We have dedicated a series of videos to establish the definition of waste and waste management, and together we have also tried to understand the foundations of the two-phase evolution of waste management. And while analyzing the second phase, if you recall, where laws and regulations played a major role in defining waste management strategies, we came across an interesting directive, which is the Directive 2008/98/EC of the European Parliament and the European Council of the 19th of November 2008 on waste and repealing certain directives. Its Article 6 specifically addressed the new term, end of waste. This directive also called for a rethinking of the product life cycle. And if you would like to review this information, you can click on the link and watch the relevant video again. But what does it truly mean to reach the end of waste status? In simple terms, it means finding and implementing the shortest path to bring a substance that has no further use for its holder to a state where it is no longer considered waste. And since this concept was introduced, scientists have diligently worked to translate the directive into actionable steps, and in my opinion, the most suitable concept to comply with the spirit of the directive is the circular economy. Its starting point was to identify the major flaw in the current system that led to the accumulation of waste. And according to the circular economy pioneers, this flaw was the take, make, dispose system, or the linear economy, as it flows in a straight direction with two open ends. The scientists have proposed a hypothesis that could potentially revolutionize the manufacturing process to address this flaw. This hypothesis suggests that by continuously repeating the manufacturing cycle of a product without relying on fresh natural resources and instead reintegrating products that have lost their purpose in the consumption cycle, we could create a resilient process that would only be disrupted by the increase in the demand. This would break the direct correlation between the manufacturing process and the natural resources in the upstream, as well as the accumulation of waste in the downstream, and ultimately reshape Earth and Knees material flow diagram. But to better understand the application of this circular economy concept, let's take a closer look at the manufacturing process. Most of us are aware that any manufacturing process consists of various phases of different levels of sophistication. Each phase may encounter faults or breakdowns, resulting in the production of scrap or non-compliant products. Let's assume such an incident took place at the very beginning of a manufacturing process, when some raw material got damaged during the handling and the other was found non-compliant. According to the traditional linear manufacturing concept, these would be considered potential waste. However, in the circular economy approach, we must rethink this decision. And instead of discarding the material, we should aim to reclaim as much as possible and reintegrate them in the production cycle. But of course, not all of the material can be salvaged. But could the other part be potentially used in other less demanding manufacturing processes? Because if so, the remaining portion of scrap and waste could be requalified as byproduct and sold at a lower price. This is how we achieve the end of waste status. Now, let's consider a full hypothetical manufacturing process and imagine that a defective product was detected at the semi-final stage. And instead of considering this product waste, and in accordance with the end of waste principle, some of the defective product is transformed into a byproduct which potentially ends the waste, and the remaining defective product is put back into the process stages to be reproduced, and in this case, waste is completely eliminated. But this is not the end of the story. When waste is reintegrated into the manufacturing process, priority is given to the shortest path, as we agreed earlier, which is the stage that is coming directly before the one where the defect was detected and referred to as R1. If this is not possible, the product is sent back one stage further, which is referred to as R2 and so on. And as you logically assume, the smaller the radius R, the more effective the process is. And in circular economy, scientists refer to the smaller radius R as the inner cycle. And they agree that the smaller the radius, the better the circular economy performance. And after implementing all these steps to eliminate waste, the remaining small portion of irrecoverable material, of course, is lost to waste. Now, if we look one level higher and add renewable and recoverable resources to the manufacturing process, we achieve the full compliance with the circular economy principles for a manufacturing process. That was only the part related to the manufacturing process. But if we refer again to Urs and Nee's material flow diagram, and I recommend that you watch the relevant video by following the link, we realize that there is a third phase in the product life cycle, the consumption, where the final product goes through a long journey to satisfy the consumer demands and eventually reaches a moment when it is of no use to him. And that's why it is vital to have this phase compliant with the circular economy as well. So let's zoom in on a specific case and talk about your mobile device to figure out how it can be part of the circular economy. Let's assume that you have used your mobile phone for a full year or so, and you are satisfied with it. However, the manufacturer announces a new model, and you decide to replace your current device with the new one. Unfortunately, this is not the optimal scenario from the circular economy point of view, and this is how you, as a consumer, can go by the circular economy book in this case. Let's assume that you were thorough and you researched the additional features in the new mobile release only to realize that there is nothing special to justify the extra expenses. And as a result, you decided to stick with your current device. In circular economy language, you have chosen to extend the use of your device as is. But what if you discovered that the new device offers a couple of new features that intrigued you, such as a new camera or advanced software? Well, in this case, you could choose to contact the manufacturer and ask for a hardware and software update, which would allow you to continue using your current device with minimal expenses And this is another form of extending the life cycle of your device through minor repairs and updates. But there may still be a scenario where you find the new device worth buying. This is where you move into another hierarchy of circular economy decisions. Let's assume that you have a younger brother who is not picky about fancy features and needs a mobile device. In this case, you could pass your current device to him, keeping it in the consumption for many years to come. This is another way of extending the life cycle of your mobile device, as it will be used as is by others. Another scenario could be that your brother is looking for a tablet or a small screen for your nephew to watch cartoons or to play games separately without occupying the family screen. Alternatively, you may need to make sure that your grandfather has a device to use as a phone in case of emergency. If you pass your mobile device to one of them, you have repurposed it for a different use and, in most cases, downgraded the product in the consumption chain for lower demanding users. And it is important to note that in this case, you are not forcing a low-grade product on a user, as both your nephew and the grandfather receive a product that is completely fit for their purposes. Finally, if the user runs out of options and none of the above is applicable, he may have no alternative but to get rid of the device. And in linear economy, this would mean discarding the mobile as a scrap or waste, but not in the circular economy era. Because instead of looking at the mobile as one whole unit, we should view it as a set of components. And here is what this means. The microprocessor and the camera of the mobile, as an example, may still be valid for use in other applications such as home surveillance systems or other simple home appliances. And in this case, components could be repurposed for these devices instead of manufacturing new ones. And this could be achieved by returning your mobile device to the manufacturer for a fair compensation to extract the valid components and resell them to other manufacturers, which means that the user has chosen to repurpose some components for other uses. Nevertheless, it is possible that some other components are not reusable and will be eventually mechanically or thermally recycled. I hope it is clear for you now the difference between waste management or recycling and circular economy. And finally, by combining both manufacturing and consumption flowcharts, we can create a comprehensive flow map of a product life cycle in the context of the circular economy, from the moment it is designed till it is completely dissolved. And this map would look like this.